Good morning students. Today we are studying next topic, conservation of momentum. Now we know that what is the meaning of momentum? It is the product of the mass and velocity. Now today we have to study the topic conservation of the momentum. First we have to write the statement of the momentum. Now it states that total momentum before collision is equal to the total momentum after collision. So when the object is striking before collision, it means it was having its mass and the initial velocity. The two objects are there of masses m1 and m2 and having their initial velocity u1 and u2. But after their striking, they will have the final velocities v1 and v2. So we are today doing the derivation of conservation of momentum. Now to derive the conservation of momentum, we are considering the object A of mass m1, B of mass m2. The object A, it is moving with velocity u1 and the object B is moving with the velocity u2. Now before collision, if you see, since the speed of the velocity u1 it is greater than the u2, so this object will strike to this. Due to the more velocity, this will strike to this, and after striking, after collision, the object m1 will have velocity v1 and object m2 will have the velocity v2. Now here we'll consider that now due to the striking of this, now the object it is moving with the higher speed, so v2 it is greater than the v1. Now what we are considering the two objects A and B of masses m1 and m2. Now first we will see that the rate of change of momentum of ball A during collision. Now we have to consider the rate of change of momentum of both object A and B. Now first we are considering the rate of change of momentum of ball A during collision. It will be m. We know that according to the Newton's second law, it is m v minus u upon t. So here we consider in the terms of m1. If we see the term m1, u1 and the v1, so we'll write here for the ball A it is m1. First you write m v minus u upon t, then we can put m1 v1 u1 and t. Now similarly the rate of change of momentum of ball B during collision will be m2 v2 minus u2 upon t. Now according to Newton's second law, we know that now two forces we are considering, force AB and force BA. Now what is the force AB? The force applied by A on B, that is the force AB, and force applied by B on A will be the force BA. So here we are considering force AB is the force exerted by ball A on B, and force BA will be the force exerted by ball B on A. Now previously we have studied that according to Newton's second law of motion, the forces are equal but opposite in the magnitude. Both will apply the equal end but apply the opposite force. So we'll write the negative sign here. The FAB is equivalent to FBA, but we'll write the minus sign here. Now we know that value of the we have already written here the rate of change of momentum for the FAB equal to m1 v minus u1 upon t. So when you substitute the values, you will get m1 v minus u1 upon t, and minus sign. FBA will write m2 v2 minus u2 upon t. This t and t will get cancelled. So when you multiply m1 with v1, you get m1 v1 minus m1 u1. Here minus sign you multiply, you will get m2 v2, minus minus will get plus, and you will get m2 u2. When you shift this minus m2 v2 this side, you will get m1 v1 plus m2 v2 equal to m1 v1 plus m2 u2. Now we have to arrange that total momentum before collision equal to total momentum after collision. So we will arrange it and write down m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So like this we will derive the law of conservation of momentum. The total momentum before collision is equal to total momentum after collision. So to start with, you have to consider the two objects A and B of masses m1 m2 moving with initial velocities u1 and u2. When they strike, the velocity changes to v1 v2. So first you will write the rate of change of momentum for ball A, that will be m1 v1 minus u1 upon t. Then we'll write rate of change of momentum for ball B, that will be m2 v2 minus u2 upon t. Now according to Newton's second law, both the forces are equal, but they are equal and the opposite in the magnitude, so we'll write m1 v1 minus u1 upon t minus m2 v2 minus u2 upon t. T and t will get cancelled. So when you will multiply and arrange it, you will get the final relationship, the total momentum before collision equal to total momentum after collision.